Okay, good afternoon, everybody, or morning, or whatever it may be when you're watching it. I just want to talk to you a little bit about quadratic functions, give you a quick definition of what they are, and then summarize all of those transformations that we did in Unit 1 and how they relate to quadratic functions. So horizontal translations, vertical translations, stretches, shrinks, and all of that. But before we begin, I would just like everyone to know that my favorite drink to drink on a Sunday night is Powerade Zero. Powerade Zero. My favorite drink. Just in case that comes up in, some type of video check. Powerade Zero. Good. Alright, so where are we at here? So let's talk about transformations of quadratic functions. And so we'll look just down here in this page and then the next page, which will be a summary. And then we'll talk about this in class tomorrow. So let's get some basic definition out of the way. So a quadratic function. Quadratic function is something that's going to have a degree of 2. A degree of 2. So it's going to have a squared in it as its highest term. The graph looks like a parabola. The parent function is f of x equals x squared, but that's not what we're going to be dealing with a lot. We're going to be dealing with the actual quadratic function, and it's basically a function that can be written. So let's say a function written in the form let's go with f of x equals a times x minus h, the quantity squared, plus k. Okay, and we got to put in here where a cannot equal 0. And we're going to do a lot of things with this. We're going to use this form to find what's called the vertex of a parabola of a quadratic function, the minimum values, the maximum values, all kinds of fun stuff. But that's going to be our basic function, basic form that you're going to deal with. Now, you've sort of seen this before. Think about this in terms of transformations. This inside here, this h, if it's positive, it shifts to the left. If it's negative, it shifts to the right. This k, if it's a plus k, it goes up. If it's a minus k, it goes down. And this right here is our vertical stretch or shrink. Okay? So that's our first basic definition. Our second basic definition is a parabola. See this right here? That's a parabola. Excuse me. I need to pause and take a quick drink of my Powerade Zero. Delicious. Alright, so anyway, as I was saying, that's a parabola right there. And the basic definition of it, it's the U-shaped graph of the quadratic function. And typically, and I'm going to kind of draw in this space right here, typically if you think to your parent function, if those are my axes, let me get that out of the way. Okay, if this is my x-axis right here, and this is my y-axis right here, the graph is centered on the origin. The origin is the lowest point, and it makes that U shape. And you can see obviously this one is going to be one that's translated that we'll deal with later. Alright, so that's the basic idea of what we're going to be working with this unit. And so what I want to just talk to you is just give you a quick summary, a quick summary of what the translations look like. Now we're not going to fill in every box here. We just want to kind of give you a general idea. So horizontal translations. Let's talk about horizontal translations. Remember we had f of x minus h, and we had f of x plus h. And as far as how it relates to quadratics, we're just basically going to say if we have a quadratic, it's going to be x minus h, but we're going to have the quantity squared, and x plus h, the quantity squared. Now what do those two things mean? Anytime you see something subtracted directly from the x, so it's inside the parentheses here and it's squared, this one means that our graph is going to move to the right. Our parent function is going to move to the right. And this one, remember, if it's plus inside or added directly to the x, this one is going to move left. And I'll squeeze that in right there. So moves right, moves left. How many units? H units. Okay. I'm not going to put anything in the graph here, so we can cross that out. As a matter of fact, we can cross them all out all the way down because there's just not enough room in there. You'll get enough experience seeing what these things look like. Alright, so a couple of hints that I'm going to give you that will make sense as we move forward. The first hint is, remember we've talked about this, anytime you have something that is inside of these parentheses, that's what we want to substitute. So I'm going to substitute my x minus h or my x plus h. Oops, got a little shade there. Into the function. So it's kind of like what you did with your assignment today, all right, where you had x minus 3 and x plus 4 and you substituted in, had to do the magic squares and or the vertical alignment, whatever method you use. Another thing I'm going to mention, I've mentioned this many times before, the transformation is inside the parent function. So we'll just say the transformation is inside the parent. Okay? So that's the basic idea behind that one. Vertical translations. What do we know? We know f of x plus k. And it kind of looks like this. Whoops, not like that. X squared plus k, we move it up. And if we have f of x minus k, it looks like this, x squared minus k, and that moves it down. So we know that. Okay, I don't think there's any real hints to give to you. A reflection over the x-axis. Reflection over the x-axis, remember it's negative f of x. And so what that's going to look like is we're going to end up with negative x squared of our parent function when we do that. Excuse me. Basically, one quick hint here. We want to multiply the entire function by -1. Okay? So maybe a better thing to write over here would be negative x squared like that, which then comes out to be negative x squared. Alright, reflections in the y-axis. Here we have f of negative x. We're dealing with quadratics. What that comes out to be is negative x, the quantity squared. Another quick hint, excuse me, no hitting allowed, is we want to substitute negative x into the function. Right? So there's that substitution. Horizontal stretches and shrinks. Remember, we have, if it's a horizontal stretch or shrink, we have f of a times x. So it's going to look like this. It's going to look like a times x, the quantity squared. So the squared goes outside. And we have stretches if a is between 0 and 1. And we have, so in other words, it's a fraction. And we have shrinks if a is greater than 1. Okay? Key thing. Key hint right here, I should say. A is the reciprocal of the factor. Okay, so a is always the reciprocal of the factor if it's horizontal. And once again, notice how it's inside here. So we're going to substitute a times x into the function. All right, and lastly, sorry, my little mouse gets in the way. Lastly, we got vertical stretches or strengths. We have a times f of x. So as we apply it to quadratics, we get a times x squared. And we're going to multiply the entire function by a. Okay? Alright, so I have this chart ready. We'll go over these examples. More importantly, just use the information from the previous page to make a description of each of these 6 graphs, and then use that information to give just a rough sketch. And don't forget, what's my favorite drink?